I think we would. All right, everyone, welcome to another lecture. So previously we did the ways of solving functions, and obviously it is pretty interesting. And I also recommend that you try to go back, go through the lectures again and again and again. I will try to decrease the size of my webcam. I don't know if you can see my face now. All right, cool. We're good now. All right, so let's begin with today's lecture, which is on finding new functions from old functions. So, finding new functions from old functions. All right, so we're going to do one master question, and each of the master questions, we're going to explain what is going on, we're going to explain the steps and whatever. Cool. So, let's begin. Master question. So let f of x be absolute value of x. Let's presume that it is absolute value of x. And we have an equation y is equal to minus half f of 2x plus 1. I'll put that a bracket plus 3. So this is our equation. So what do we have? We have f of x. So step 1, observe the equations. So we have f of x being absolute value of x, and that y is equal to minus half f 2x plus 1 plus 3. So that these are the two things that we have at this moment. Cool. Now, get the initial horizontal first. So what I mean by initial horizontal is that this f of 2x plus 1, this is the inner part. So this is where the horizontal lies. So it's not 2x plus 1, it is 2 of x plus 1 of 2 of x plus 1. So what we see, get the inner equation first. So step 2, inner equation. You see that f of 2 of x plus 1, that x plus 1 moved from x to x plus 1. So this means it shifted towards the left by 1. So this, why are we saying shifted towards the left? Because if you say x plus 1, you're always going to presume that x plus 1 is equal to 0. And so when you say x plus 1 is equal to 0, x being minus 1. And because you get x as minus 1, you always need to consider that this function is equivalent to 0. And that x plus 1 is equal to 0. So 2 of x plus 1 is 0, and then x plus 1 is 0, like that. So here x plus 1 is equal to 0, x being minus 1. And because x is minus 1, because now you went from 0 to x being 0 to x being minus 1. And because you have x being minus 1, you shift 1 to the left. And so because it went from x to x plus 1, it shifts that equation there. So the equation or the behavior of that equation, the equation position shifts to the left. So it will shift to the left, right? So x plus 1, so that is the inner equation that will shift to the left. Cool. Now we have 2x plus 1. So what we know that x plus 1 shifts to the left, right? X plus 1 shifts to the left. Now 2 of x plus 1 is equal to 0, then I can set 2x plus 2 is equal to 0. Nope. Wait. My bad. Inner equation, function inner equation. We're going to call it function inner equation. So f of 2x plus 1 is equal to 0. Then 2x plus 1 is equal to 0. And if x plus 1 is equal to 0 by 2, wait. Hmm. Ah, this equation is a factor of 2 in horizontal scale. So if it enlarges by 2, it's going to compress. So it's going to like enlarge by half, right? So this will compress by 2. You're going to go from x to x by 2. You're going to go from x to x by 2 because it compresses by 2. And now when you apply the function, apply the function. So f of x is absolute value of x. So f of 2 of x plus 1 being absolute value of 2 x plus 1. And because this compresses by um, 2, then you're going to have the vertical scale being half to x plus 1, right? You're going to have half to x plus 1, and also there is a reflection, right? So there's a reflection amongst the x-axis, minus half to x plus 1. And so now the equation that you have, this equation here, this f of x, this minus half is this minus half here. If I bring that equation actually, so this equation here, you see, so instead of this guy here, we're changing it to 2x plus 1 plus 3. So this is our equation. So there is a shift to the left, compressed, the shift to the left, the shift to the left, compressed, and then there will be a reflection. So there will be a reflection. And so when you do that, y is equal to, so you do x is equal to 0, y is equal to 1, you keep on doing that, you're going to get a graph like this. You're going to get a graph like that. This is 3. So at 3, you're going to get the highest point and then goes down again. Cool? Good? We'll do another one. One more. F of x is equal to root x, and we have y is equal to minus 3f half x minus 4 minus 1. So we have f of x is root x. So this is the equation that we are focusing on, and y is equal to minus 3f half x minus 4 minus 1. Step 1, the inner shift. So if I write the equation again, I'm going to write the equation cleanly. So y is equal to minus 3f half x minus 4 minus 1. This is what we're focusing on. So f of half x minus 4. And this point. Therefore, we're going to have x is equal to 4, shifts 4 times to the right. 4 times to the right. Cool? And then horizontal shift. we have half x minus 4, but because we have half x minus 4, which means it enlarges by 2 times, so stretches by 2 times. So this stretches by times 2. So x becomes 2x, and here it shifts 4 to the right. So the minus means shift to the right, plus means shift to the left. If you have a half, then it enlarges. If you have a 2, then it compresses, right? So this stretches by 2. Now apply the function. So if I have f of half x minus 4, and I know that f of x being root x, then I'm going to have root of half x minus 4. And what was my equation? What was my general equation this here? This is the so apply. So this is step. We got the step inner shift. We got the horizontal shift. Now what we have to do is call that function. Call the general equated function. General equated function and substitute. So I know that f of x is root x. So therefore root of half x minus 4. And now call the y equation. And your y equation is minus 3 that minus 1. You can have minus 3 root of half x minus 4 minus 1. So it's going, then you plot the, x equals 0, y equals 1, x equals 2, and so on and so forth. And when you do that, it's going to go like that. So it's a square root. It's a square root graph, but because you have a negative, it's going to point here, right? Something like that. Cool. So if you keep going and going and going and going and going, so it's going to go like, it's going to slant down and then stay flat, 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 flat. So it's going to go flat. Cool. All right. Um, so this marks the end of section 1.4. This is probably one of the easiest one. Core thing is that you focus on, so let's go through the steps. Let's use this as an example. So you solve the x minus 4, meaning it shifts 4 to the right, and then now you have a half, which means it's going to stretch by 2. So now you have your f function, and you know that f of x is root x, so you're going to have root of half x minus 4. You substitute that here, and then minus 3 times this function, bring it in minus 1, and then you see there is minus 1, so which means it is going to stay in the negative. Cool. So that marks the end of section 1.4. Pretty easy, pretty simple, and I'll catch you on the next one.